Hello everyone. I am Ayush Agarwal from ABES Engineering College, Ghaziabad. So today we'll discuss about the constraints used in relational model. So in our previous lecture, we have already understood the concept of relational model, basic concept of relational model, about its structure, about its object, about its importance. Now, today we'll discuss about the concept of constraints in relational model. So we'll discuss what is constraint and its types. So if we talk about the constraint, so we have used the relational database concept, and we know that in the relational database, we have a collection of relations. We have different relations, right? And under these relations, we have a different kind of attributes, and under that attributes, we'll store our data in a particular relation. Now, these relations stores data about a particular business process. For example, we'll manage a relation for the students, so we'll insert the student's information into that relation. We have a roll number, we have name, we have age, we have branch, we have year. So we have different kind of attributes in that. Now, functional users define the rules that must be applied to this data before storing it in the database. So basically, constraints are the rules which we can apply on the relations before the data gets stored into it, right? Let's understand with the help of an example. So each student must have a roll number which must be unique in the record maintaining student data. So this is a kind of a constraint we have to apply on the relation, that if we have a roll number attribute in a student relation, so every student roll number must be unique. No two students must have a same roll number, right? So this is a constant we have to apply onto the relation. Another example is no student in a department can work on more than one mini project. So this constant we can apply on the relation. So if any student exists in the department, they can work on more than one mini project, or they cannot work more than one mini project. Another example we can take, a student can belong to only one department. If a student exists in a relation, so it can belong to only and only one department. It cannot belong to more than one department. So these are some kind of constraints we can apply onto the relations. Now, if we talk about the definition of constraint, basically, so the business rules or restrictions which are enforced on the data being stored in a relation are called constraints. And these constraints ensure that the data stored in the relation will be valid, right? Let us take another example. For example, if we have a relation of a student, have different attributes like roll number, name, and let's suppose age. And we know that age cannot be negative, right? If we want to store the information about the student in the relation, so if the value of age will be negative, it cannot be stored into the relation. So it also ensures that the constraints also ensure that the data which is stored into the relation is valid, right? And one more important point to be note that even if a single column of the record being entered into the relation fails or constraint, then the entire record is rejected and not stored in the relation. So for example, let us take a student relation, and we have three attributes into it. We have roll number, we have name, and we have age. We have correctly entered or insert the value of roll number and name. Let's suppose roll number will be taken as 101 and name is taken as A. But by mistakenly, we have taken the value of age is -1 or -23, let's suppose. So the value of age is invalid. Because of this value only, the whole record cannot be inserted into the database. If any value of a particular column of a single column is failed to be a no to create a constraint, then the entire record cannot be stored into the relation and it is being rejected, right? So this is the basic concept of constraints in relational model. Now we have different categories of constraint in relational model. So basically we have three categories here. First of all, we have inherent model, base constraint, or implicit constraint. We'll discuss one by one with the help of an example also. So first of all, we have inherent model. based constraint or implicit constraint. Secondly, we have schema based constraint or explicit constraints, or we can say that integrity constraints. And lastly, we have application based constraints, right? So let us discuss one by one. First of all, we have inherent model based constraints or implicit constraints. So basically, these are the constraints which the relation must follow before the data being entered into it. And we can also say that these are the constraints which follow the characteristics of the relation. We have discussed the characteristic of the relation in our previous lecture. So these are those constraints which are follow the characteristics of the relation, right? For example, these constraints are ordering of tuples in the relation. So we have already discussed in the previous lecture that order of the tuples in the relation do not need to be significantly, right? It means that the order of tuples in the relations do not matter. If we have two different relations and under that the order of tuples in same relation are different, so can we say that the relation is different? No, right? So it means that the relation, in a relation, order of the tuples does not matter. Secondly, we multi values and nulls in the tuples. What does it mean? We have already seen that multi-valued or multi-values are not possible in a relation. For example, we have seen that in a case of phone number, anyone can have more than one phone number. So can we place both or two or more than two values in the same column? No. So multi-values are not possible into the relation. And the value of null, whenever we don't know any value, so in place of placing the value, we can place the null in the tuples, right? So example, a student does not have middle name in the student relation, so it will represent by the null, right? And these are the inherent model based constraint or implicit constraint, which means that these are the constraint automatically applied when you create a relation or when you are entering the values into the relation. Okay. Now, second type of constraints are integrity constraints. We have seen that we have three type of constraints: inherent based constraint or implicit. Now we'll see about schema based constraint or explicit constraint, or we can say that integrity constraints. Now, these type of constraints are used to ensure accuracy and consistency of the data in the relation database. What does it mean? It means that, first of all, it is also called as schema-based constraint or explicit constraint. What does it mean? It means that we have to apply the particular constraint onto the relation. It does not no, automatically or inherently applied onto the relation. We have to apply, right? Now, these type of constraints are used to provide accuracy and consistency. So basically, if we talk about the relational database, accuracy and consistency is one of the major parameters which have to be ensured and which have to be properly ensured to improve the quality of the database, right? Now, if we talk about the integrity constraint, these are further categorized into different kind of constraints. So first of all, we have entity integrity constraints or key constraint. Secondly, we have referential integrity constraint. And thirdly, we have domain integrity constraint. So we'll discuss one by one. So first of all, we have entity integrity or key constraint. What does it mean? Basically, entity integrity or key constraint is based on the concept of primary key. Now, what is primary key? Basically, every relational database or every relation has a primary key, which ensures that no two tuples must be same, or it ensures that there are no duplicate tuples in the relation. So it is a major component of the of overall data integrity, which ensures that there should be no duplicate tuples in the relation, right? How does it ensure that? By placing some constraint. What kind of constraint? So basically, if we talk about the primary key, every one should aware that the values of the column which we have imposed as the primary key should be unique. Every value should be unique. And secondly, no null values should be placed into that column. So for example, in this example, we have taken department ID as the primary key. Now you can see that all the values under department ID is unique, right? We have 001, 002 up to 005. So no two values should be the same, right? And second point or second property of the primary key is that we cannot take null value into it, right? So if any primary key, if any column, if you impose a primary key onto any particular attribute, so it must be unique and it should not have any null values. So this is the concept of entity integrity or key constant, which based on primary. Now, secondly, we have referential integrity constraint, and it means that or it is based on the concept of foreign key, right? Now, what does it mean, or what is foreign key? So basically, if a relation R2 has a foreign key attribute matching the primary key attribute of other relation R1, then every value of foreign key in R2 must either be equal to the value of primary key in some tuple of R1, or the foreign key value must be null. What does it mean? We can understand with the help of an example. So you can see that we have two relation here. First one is a department, and the other one is of course, right? Now in department, we have different attributes, and among those attributes, this department ID is treated as a primary key, right? Now, in the course table, we have taken this department ID as a foreign key. So basically, first point of the foreign key will be the primary key of the relation will be the foreign key of the other table. So here we have the department ID. This is the primary key for department table, and this is the department ID. This will be treated as foreign key for the course relation, right? Now, there are some properties of the foreign key. What are those properties? So unlike primary key, we can have duplicate values into the foreign key, right? So first property is that we can have duplicate values into the foreign key attribute. Okay. Secondly, can we place null in the foreign key? So yes, in some cases we can also place null unlike in the primary key. Now the third point, what the values should be placed in the foreign. So here you can see that we have different values, right? We have different 5 values here, department D01, D02 up to D05. And in this case, we have different department names or department values. Now, if I want to insert department number 06 or D06 into this foreign key or this for this attribute, we cannot place that. Why we cannot place that? In this particular value or in this particular attribute or department ID treated as a foreign key, we can only use the values that has already been stored in the primary key of the other relation. We cannot use any other value. So here, you can see that these are the 5 values, and only these 5 values can be used in the foreign key. No other value can be used here, right? So this is the concept of foreign key, and referential integrity constant is based on the concept of foreign key. Now we have domain constraint. So basically, these are the constraint which specify the set of possible values that may be associated with an attribute. For example, we know that what is domain. So every attribute is associated with a particular domain which specify its type, the format, and the set of possible values that can be stored into it. Right now, in domain constraints, again, we are using different kind of constraint, right? So first of all, we have null constraint, we have unique constraint, we have check constraint, and we have default constraint. So we'll discuss one by one. Now, what is null constraint? As the name specifies, this is a constraint, or it specifies whether values which are permitted to enter into the relation should be null or not, right? We have a particular constraint known as not null. So not null constraint makes sure that a column does not hold null values. If I want to create an attribute where I don't want to insert any null value, even if I don't know So I cannot place, while the creation of the table, while the creation of the relation, we can place that attribute as not null. And whenever any attribute which are placed as not null, then the values stored into it cannot be null, right? So when we do not provide a value for a particular attribute while inserting a record into a relation, it takes null value by default, right? So if any attribute is not taken into account and is not treated as a not null, and while in inserting a record into a relation, any particular value we do not need or we do not understand, so we can take null value as default. Now, what is unique constraint? So basically, unique constraint is a constraint where any attribute values can be unique. No duplicate values are allowed, right? So for example, I want to create a particular attribute and where I don't want the repeated values. So for that attribute, I need this kind of constraint, that is unique constraint, right? So it is a rule that forbids duplicate values in one or more column within the relation. This constraint is also used to implement secondary or alternate keys. What are these alternate keys and secondary key? We'll discuss in our future video. But these constraint is also used to implement those keys, those type of keys, right? And attributes declared as unique are permitted to have null values unless they have been explicitly declared not null. What does it mean? We have two kind of constraint. We have not null constraint, we have unique constraint, right? If any attribute is taken an unique constraint, so we can insert a null value into it, unless that attribute is taken as a not null constraint also, right? Similarly, if for any attribute, if an constraint of not null is applied into that attribute, so we cannot use null values there, but we can use duplicate values there, right? But if we combine these two constraints, we combine unique and we combine not null constraint, then we get the primary key, because the primary key holds the two properties. First property is that all the values should be unique, which should be followed, which should be used by the unique constraint. And the other property is that we cannot insert any null values. So that should be used by the not null constraint. So one, we have primary key as a constraint, which is referred as the integrity constraint, right? Secondly, we have not null and unique constraint. We know that in a relation, only one primary key is possible. So you can use that constraint as primary key onto only one attribute. But if you want another attribute to be treated as primary key, then you should use unique and not null constraint simultaneously onto that attribute. Okay. Now, next we have check constraint. So basically this constraint is used to check the value before it's stored into the database, right? It is defined on a column for specifying the range of values that can be inserted into it using a predefined condition. So as I have already mentioned an example of age, so age cannot be negative, right? So whenever the value of age is inserted into a relation or a particular attribute, so it will be checked by the constraint known as check constraint. If the value meet the predefined condition, then only it will be allowed to enter into the relation. Otherwise, it will be discarded, right? Also, here another example is being taken, that we understand that the salary of the faculty cannot be negative value, right? So if we take a salary of any particular faculty member of an employee, so whenever we want to insert a particular record of a faculty member of an employee into the relation, so we must ensure that the salary should not be negative. Whenever we insert the value into the relation, so we must check first whether it will be negative or positive, or whether it will be meet the predefined condition or not. It will be checked by the check constraint. Now, next we have default constant. So what does it mean? Default constant is defined to provide a default value to a column if no other value is provided while inserting a new record. For example, let us take an example. Right. So let us take a student example. Okay. So we have a student relation, and under that, we have no, different attributes like roll number, name, age, and branch, and let's suppose address. Okay. So if I want to insert a particular record into it and I don't know the address of that student, right? If I don't want to, if I want to store the data of a student and I don't know the address of of that student. So there will be two cases. First of all, we can place null into that particular attribute, right? Second, we can use this default constraint if we do not want to place a null value into it. So we can use this default constraint, and whatever the value we want to place into that attribute, if we do not know the value of that attribute, so we can use this default constant. So in that case, in address attribute, we can use India, right? So this is the case of default constant. uh, Another example, the default value for the column of research project relation can be taken as an ongoing. So if we do not know the status of the research project in a particular relation of research project, then by default, when we insert a record into it, so it will be taken in as an ongoing, right? So these are the kind of default constraints. Now, thirdly, we have application-based constraints. Now, this type of constraint we cannot directly express in the schema, or you can say that these are the constraints which cannot be inherently applied, which cannot be applied using the schema, using the schema-based constraints, right? Now, these are the constraints which must be enforced by the application programs. Whenever we create an application program and embed the database into it, so we will use those application programs to enforce the constraint onto that relation. These type of constraints are known as application based constraints. So for example, a student can take a maximum of 25 credits in a semester. So we'll use the application programs and specify this constraint while no, creating a database, right? So this kind of application, this kind of constraints are known as application-based constraints. So this will be all about the constraints used in relational model. These are the references through which the content is being used or taken. Thank you for watching this video.